So let's start our class this time. Now this is for October A2 Physics batch. Yes, we will start. Now, obviously, in my classes, there are going to be three types of files. One is going to be your written PDF or the PDF notes, from where you can understand the definitions and everything. Other than notes, you're going to get class slides, like everything I'm going to draw or write on the screen in order to explain one concept. That will be considered as class slides. And then again, after class slides, we're going to have worksheets. Right, worksheets are also kind of materials we're going to provide. Worksheets are basically nothing new. I mean, I'm not going to make the questions entirely from scratch. The worksheets are actually questions taken from your Galvanize question paper. So what I will do is that I'll try to take out questions from the year 2016 to 2019, 2019 or 21 or 22, as far as I can. And I would arrange those questions according to chapters. So, for example, if we are done with our maybe further mechanics, we will do one worksheet based on only the questions from further mechanics. Okay. So basically, I'm going to arrange the questions taken from your actual question paper and arrange them in under the chapters section. So we're going to do worksheets also. Problem is, as this is a crash course, I will actually not get enough time to entirely finish all of these worksheets in class. So mostly what I will do is that I will obviously explain the concepts in class, but for the worksheets will be actually provided in as a form of recording. So I'm going to give you the recordings for that worksheets after we are done with one concept. And then again, even after watching the recording, there are some questions or problems that you could not understand from my explanations in the recordings I have provided for the worksheets. For those cases, we are going to provide you tutorial hour so that maybe after solving like 3 to 4 worksheets, if you have any problems from all those 3 worksheets or 4 worksheets, you can write down your problems and then present your problems to me in the tutorial hours. So then I can solve it as clearly as I can. Okay. And other than that, obviously, everything will be arranged in our classroom. The problem is our October 24 A2 classroom is not as designed yet, but this is how the classroom would look like. I would suggest never look up from the screen. This is actually for the AS October batch because it's quite perfectly organized. So I'm using this classroom as a model. Like this is how your classroom would be. Now, this is their classes, and on the screen part, you can get all the recordings, all the worksheets, all the classes we did. You can get all the recordings over here. But in the classwork, you can see, get everything in a categorized portion. For example, everything we did in Unit 1, note, class slides, and recordings for that particular topic will be arranged in this kind of pattern. For your A2 classes also, we're going to create a classroom in this kind of arrangement that maybe after doing further mechanics, the notes for further mechanics, the written class slides for further mechanics, and if there is any worksheets available, you'll also apply, like add those things in your classroom in this kind of files section. So it will be easier for you to get access to all the materials and recordings over here. And then again, one thing, I actually share my class recordings privately with with the class students. So what you can do is that you have to log in into this classroom with the email which we have full access to. So I'm only going to share the class recordings with that email only. So you can actually access. Sorry, 1 minute. Right. So as I was saying, that you are only going to be able to access that recording using that email only. Okay. So make sure that whatever, like if you continue with my classes, if you're going to join the classes and make sure that your email is quite perfect, like you know the passwords, you know that which device the email is logged in or something. And again, if you forget your email and maybe there's some problem with your email, you can certainly ask me to remove that email from your classroom and you can join the classroom again with a different link. And if you're going to join the classroom with a different email later, that will not be a problem. You can still get all the things that was previously added to the classroom. Okay. Then we will start. This was all for the classrooms, and this is our class slides file. Okay. Let's start with a little bit of specification, and then we will start with our main chapter 1 today, because this is a trial class, and I'm not going to waste this entire 1 hour, 1 or 30 minutes in just introducing the entire course. Okay, we are going to start with further mechanics today, so that you guys can understand a few about how I teach the concepts or how my teaching methods are, and if you guys are getting like understanding by teaching methods of all. Right? So we're going to finish with the mechanics today, mainly momentum. Now in A2 physics, obviously we have similar to AS, we have three units, unit 4, unit 5, and unit 6. Okay. Unit 4, you have three chapters, and then again, unit 5, you have three chapters. Now, these are actually all the subtopics you can actually understand, you can actually get from your concepts for under each chapter. Problem is, our student book that was actually prescribed by your Edexcel Pearson is not that much up to level. Okay, it is good for understanding the basics, but problem is A2 physics is quite very in depth. So just understanding the basics will not actually explain you a lot of things. So that's why we are going to actually have to rely on notes also. Because there are some topics which are actually not described in the book, but they will ask you those kind of things in question paper. For example, the difference between momentum and Newton's third law and second law. This thing will not be described in your book or mentioned in the book, but this is a very important and common topic for your Unit 4 question paper. They usually ask 4 to 5 marks of question from this topic, but they never mention this in your student book. So if you want to maybe, read some book, then I would suggest obviously read your A2 student book too. But other than that, in our classrooms, I will be giving you the PDF for Hodder A2 book. Right. In case if you cannot buy the book, you can obviously read the PDF and understand few concepts. So I would suggest follow two books for A2 physics. That is your A2 student book 2 and then your Hodder book. Hodder is Hodder is also A2, I think. Yeah, Hodder doesn't have any student book 2 format. Hodder is A2. Hodder A2, Hodder AS. So I would suggest reading these two books is enough for your understanding for concepts of basics. Or if you think that under like reading book will actually improve your writing pattern also, because in A2 also you have those star mark questions, right? I think for me in my A levels, reading these two books actually improved my writing pattern. Like it would make me very clear how to describe a certain situation in very small words or in a very collective words. Right? So I would suggest read two books if you have time. Other than that, similar concept, we're going to do question papers after every chapter. These question papers will be arranged in chapter-wise format, and we will solve that. And first one, I will solve this in a recording, like entire questions, all the questions from that worksheet will be solved as a recording format for your batch. And this second homework is going to be, like second worksheet is going to be a homework. Right. I would upload this into your classroom, and you guys have to solve that and submit your working as a PDF. Okay. They will be obviously folders where you can submit your files in the form of PDF. And then again, in Unit 6, you do not have anything extra. Unit 6 is basically that there are few core practicals selected from Unit 4 and 5. And Unit 6 doesn't actually have that much of different content, okay, that much of different specific highlights. And that is basically an extended version of Unit 4 and 5. I mean, for example, if I go to this Unit 6, this is Unit 6. These are the 8 core practicals for your uh, A2 physics. And for example, the first one is from Unit 4. Right. So similarly, all the others are going to be either from Unit 4 or 5. We're actually going to understand the basics of the core practicals in our regular classes for Unit 4 and 5. And then again, in Unit 6 classes, we'll explain how to actually perform an experiment for these kind of cases. What would be the safety procedure? What would be the um, dependent and independent variables, how to change a particular quantity for the entire experiment, right? Those highlights will be discussed in our Unit 6. In Unit 6, I'm not going to explain every basic of these concepts. The basic of these concepts will be explained in our Unit 4, Unit 5 theoretical classes, and the safety procedures, overall process for carrying the experiment will be discussed in our Unit 6 classes. And other than that, as we're starting from June, right? So you basically have June, July, August. I'm actually considering I'm going to have like these 3 months. I'm not going to consider having September, because September that will be needed for our mocks and mock solving classes, year wise, right? All those things will be needed for September. Since our exam will be in most probably October 23rd or something. I'm not sure, but bio student, is that Bishama you?
Yes, ma'am.
Okay, I think you gave me the files, right? That when the October exams will be.
Yes, it's on October. It's starting in October last week.
Oh, it's
Uh,
October last week. That means I think you gave me the file maybe starting from
yes,
2023, right?
the date I'm not sure, but it's somewhere in the last week of October.
Right, so last weeks of October.
Yeah.
Okay, so I'm considering like from 20th October to onwards, right? From then our exams will start. But then again, obviously, I would not suggest having classes in October because you guys might be sitting for other units too, and those subjects might be appearing before 20th, right? So for October, what we will do is that we are going to have few extra tutorial classes, but we need to finish our entire syllabus before October. We cannot extend our syllabus finishing or question papers within October. So my planning over here would be that for the entire June month and first week or 2 weeks of July, we're going to complete our Unit 4. Okay. So full June is Unit 4, and over here, first 2 weeks is Unit 4. And then again, from here, the rest of the 2 weeks for July, 2 weeks is going to be Unit 5, and this entire August is Unit 5. And that means the first week of September, as I've stated, that Unit 6 is not that much extremely big or new things to introduce you with. So that means for September now, we're going to start with Unit 6. And even Unit 6 is extremely small. So I'm expecting that within 1 week, I can actually finish the all four practicals and the introduction for Unit 6. Introduction is basically how to use vernier caliper, micrometer screw gauge, resolutions, understanding the accuracy level, percentage uncertainty. These are the basics of unit 6 and 3. So we're going to understand that in our Unit 6 introduction class. And after that, all these A4 practicals can be actually discussed in 3 to 4 classes. Okay. So in September, then, okay, thank you. Then our example starts from October 23rd, right? Okay, so in entire September, we'll complete Unit 6. Also, what we have to do from July, last weeks of July, we'll actually have to do question papers also, question papers of Unit 4. Right, so over here, we're also going to start QP of Unit 4, and we are actually going to start solving question papers from 2020 to the recent paper. Okay, whatever year is available. I am quite sure that May paper would be available, but sorry, Jan paper is available, Jan 24, but I'm not sure if I would get access to May 2024. But I will try. If I can get access to May 2024, then we'll also try to solve that before our exams. So basically, we're going to solve question papers from 2020 Jan to the last session. I'm considering that 2024 Jan, okay? I'm not considering the May session paper yet because I don't have it yet. So these are the papers that are solved. So these are the papers that we are going to solve in our Unit 4 classes, Unit 5 classes, and also for Unit 6. In paper solving classes, what I will do is I will give I will take entire one class to complete entire paper for all of you. For example, maybe on 28th July, I will take maybe 2 hours of your time, and we're going to solve maybe 2022 Jan paper, entirely Unit 4 Jan paper. We'll solve in one class. So in that case, what would happen is that you will understand how to actually read the question, how to take that hidden points from your question, and how to actually answer a certain question. So it would be easier for you to then practice your questions on your own. So mostly what we'll do is that I'll give you the solution for one entire paper entirely in class. And after that, you guys need to complete other papers as homework, and you guys have to submit the problems in our tutorial classes or our question paper solving classes. Okay, that will be discussed in the second week of July, that when we are going to have our question paper solving classes. Mostly in that case, we would have to increase our class timing. Like for example, now we are having 3 days. Then in July, we might have to need to increase it to like 4 days a week, right? But then again, I'll obviously try to make sure that even if I increase the number of days, it would never try to. I will try to make sure that it never clashes with any other of your classes. Okay. Similar process in August also, like by the end of last week of August, we will be done with our Unit 5. So from then again, our Unit 5 question papers will start. And then for the entire September month, our Unit 6 and 5 question papers will continue. And for every unit in A2, we are going to take at least 5 mocks, and there are no actually payments for extra payments for mocks. Mocks payment, I mean, entire mock fees and everything is included with your monthly fees. Okay. So there's no extra payment for your mocks. Now, over here, we're actually going to take at least 5 mocks. And if we have more time, in that case, we might take more mocks for that case. For example, in A2, Unit 4 is the toughest. See, Unit 5 and is mostly theoretical. It doesn't have that much maths involved. Unit 5 and Unit 6 does not have that much complexity. So I will try to actually take more mocks for Unit 4 because it's extremely tough for everyone to understand. It's mainly maths. So Unit 4 is difficult. But Unit 5 and 6 is not that much difficult. So for Unit 5 and 6, um, on max or on minimum also, we can only take like 5 mocks, Unit 4 and 5, so 5 and 6. And for Unit 4, we're going to take as much mocks as we can. At least 5 will be taken. But if we have more time for Unit 4, actually, we're going to have more time, right? For August will be available, September is available. And then again, October first weeks are available. So I will try to make as much mocks as I can for Unit 4. And also, our mock papers will not actually be anything copied from a question paper. All the mocks we're going to do will be extremely hard and entirely new. Because the main motive of mocks is not to do good in mocks, right? It's just there to make you practice and prepare for a very tough question paper that might arrive in your session also. So I think solving unseen question papers is better than solving seen question paper. So this is it actually. Is there any question from all the things we have stated? Any problem with the overall procedure of how we're going to finish this crash course?
Hello, I have a question.
Yes.
As you said that Unit 4 is tough. Like, how tough is it exactly?
No, this is not like entirely tough. Problem is, uh, we are not actually prepared to solve maths in physics and biology type of question, right? I think
Okay.
that's where student gets stuck in that. I mean, if you practice
Uh-huh.
question papers for Unit 4 as much as you can, then it will not be a
Mm-hmm.
problematic for you.
So is it okay if I start with like the old specification papers first? Uh, I use it as a warm up.
Yeah, sure, obviously, no problem. I mean, in
Okay.
Unit 4, from the old specification to new specification, there is nothing that
Uh-huh.
much different. Right? Most
Okay.
of the contents are same, so obviously you can do that.
Okay, sure. Thanks.
I think you actually missed the initial parts of the classes. In the initial parts, I said that after every chapter, I'm going to give you worksheets, and those worksheets will actually be questions taken from your old specification, from
Mm-hmm.
2016 to 2019.
Okay.
So you would not need to solve the old specification questions separately. You can solve that
Uh-huh.
by following the worksheets.
Okay, sure.
Any questions from any other one?
Miss, how will mocks be conducted?
Mocks will be conducted in online. You guys need to turn on your camera, and then I would actually, fix the timing. Usually the timings will be like 1 hour, 20 minutes, 10 minutes less than your actual question exams, and you guys have to solve the paper within that time duration inside the Google Meet. Like you have to be in the Google Meet, your cameras has to be turned on, and I can so that I can see you solving the paper. And after the mocks are done, you can make a PDF and submit your file in our Google Classroom.
Okay, ma'am, thanks.
Okay, so yeah, this is it. I think all of you already have our class routine. You might not have a class routine. I just give you the class routine on. I'm actually not sure the time durations. For example, Bishama is from Sri Lanka and Ilas and Safia, they are from uh, Qatar. So Safia is from Dubai again. And Nadra, are you from any other places?
I'm from Tanzania, Dodoma, Tanzania.
Okay. I actually don't know the time difference for all of these places. I'm
It's
so
fine.
sorry. Right.
Like
So
over here, it's like 5:27 p.m. right now.
the same time duration as Dubai then. Okay.
Mm-hmm.
Then in that case, I will actually first, this is for Bishama. Okay, the classes will be on Monday, Wednesday, and Thursday. That is going to be 10 for me, so 9:30 for her. Yeah.
Yes, ma'am.
And we are half an hours earlier. Like we have a time difference of half an hour. Our classes will actually be of 2 hour duration. I know that's actually a long period, but we need to finish all of these things within a very short time. So I cannot actually take just 1 hour and finish all of these things within an hour. That is not possible for me. So I need to have 2 hours of this class. I'm really sorry for this. This is going to be 11:30 for you. And for other people, we have a time difference of 3 hours from my time. I think for Natra, Ulas, and Safia.
It's fine.
Thank you. Now for other people, the times are going to be 5. No, sorry, that's 10. So it's going to be 7 p.m. So,
Okay.
right, from 7 to 9 p.m.
Uh,
So it's not going to be 5 p.m.
No, the timings were not supposed. You're from Qatar, right? No, the timings are supposed to be like 10 minus 2, yeah, 7 p.m. The 5
No, I
p.m.
live in. I'm not from Qatar.
Yeah, I think only for this today's extra class, we are going to have the class at 5 p.m.
The rest is 7. Okay.
Yeah, the rest is 7. This is just an introduction class, right? For the trial class. This is not a regular class. Regular classes will start from tomorrow.
Yeah. Okay.
So this is for Sri Lanka, and this is for Qatar, Dubai, and other places. Then we will actually start our class. As I've stated, I cannot waste today's class. In today's class, we are going to complete momentum of single motion, change in momentum, law of conservation, collision, impulse, explosion, and energy can also be related, this and this. Yeah, we have to explain all of these things except for angular momentum. I'm actually keeping this for the next class. Okay, so that we can actually finish this entire momentum within 2 class. And then that means from this week, Wednesday onwards, we can solve our worksheet. 1 minute. But again, this is our specification file. This will be uploaded in our classroom, and also we can create a WhatsApp group where this type of files will be shared before our classes. Okay. So if in case you want to go through the files before the class starts, you can obviously get that from your WhatsApp. So this is your momentum file. Now this is part 1. Obviously in part 2, we are going to have angular momentum, right? This is for just linear momentum. Linear momentum means what happens in air reverse, that we're not going to only understand momentum in one plane. We have to understand momentum in 2 planes also. But that 2-plane angular momentum, I think if you remember from your AS, cos component, sine component, those concepts will be related in your momentum parts also over here. Not that much tricky. I mean, all the concepts over here that we're going to understand from linear momentum will also be applied for angular momentum, only the calculations are different. For angular momentum, we have to introduce with cos component, sine component, but on a linear momentum, the calculations are actually quite similar. In your question paper, they ask you questions about linear momentum very less, because linear momentum was already introduced in your AS classes, right? The calculations we did in our AS classes. So in A2, they would actually give you, like, they're more interested in angular momentum concepts for maths. Otherwise, the theoretical concepts for linear and momentum are all similar. For example, conservation of energy, relationship for momentum and Newton's first law, third law, second law, third law, and change in momentum over time. All of these concepts will actually be similar for linear and momentum. Only the calculations are different. And in your exam paper, it is very rare that they're going to ask you calculations from linear momentum. they will or you can actually assume that they will never ask you calculations from linear momentum. They will mostly ask you questions from your angular momentum. The calculative part will be mostly for angular momentum. Now let's start. Then again, this file is also will be shared with you in WhatsApp and your classroom. Okay. After this class, I will actually send you this file to all of you. But I think for Nadra, did you send me a WhatsApp? Because after this class, I don't know how to actually reach you.
Yeah, I'll text you, I guess. Miss Mohima, right?
Right.
Yes, I have your number. I'll text you.
Okay. Thank you.
Okay.
Now we will start over here. Like obviously, basic thing from our AS, from our I think IGCSE classes, right? That linear momentum is something of our body that is defined as the mass of product of its mass and velocity, and this is its equation. Now, I actually don't memorize if a quantity is a vector quantity or a scalar quantity. There's actually a simple math for it, that is dot multiplication. In dot multiplication, there are some assumptions. All the scalar quantities, as they do not have any directions assigned, right? So all the scalar quantities are assigned with positive signs, and all the vector quantities are assigned with negative signs. So from your equation for momentum, since that is what? Mass into velocity, right? 1 minute. Momentum is mass times velocity. Over here, mass is certainly a scalar quantity and velocity is a vector quantity. So mass turns out to be plus and vector negative. So the product of this plus and minus would be eventually negative. So the final sign for your momentum is negative, representing that momentum is indeed a vector quantity. So if momentum is a vector quantity, in that sense, it will obviously depend on magnitude or it will depend on direction, right? Now, so many people think that both of these things, magnitude and direction, must change for an object's momentum to change. That is not the case. If the object's magnitude is changing, the direction is same, in that case also, the overall momentum is changing. And then again, if an object's magnitude is same, the direction is changing, in that case also, the object's momentum is changing, right? For example, an object is moving with an object is moving in a straight line. Straight line means obviously direction is constant, right? But the value for magnitude changes. I can give you a very small example over here. In all these cases, the magnitudes are not same. For example, over here, the magnitude was maybe 5, 6, 7, 8. You can clearly see at every point, the direction was same as they were traveling in a straight line, but the magnitude changes. That means overall momentum changes. But then again, if an object is traveling in a circular pathway, and for every point, the magnitude is same. At every point, the magnitude is 5. On a circular pathway, direction continuously changes, but magnitude is constant over here. So even if your magnitude is constant and direction is changing for the entire pathway, in that situation also, I will consider the overall momentum to change. Is there any problem from these two parts?
No.
Okay, then now we're going to move on to the second part, which is basically the units part. Right, for example, in momentum, again, according to the equation, mass velocity, mass, the SI unit for mass is what? Kg, right? So this is kg, and for SI unit for velocity, that is going to be meters per second. Quite similar to the unit for force, right? The base unit for force was kg meter per second square, and this one is kg meters per second. That is because they're actually related. We'll understand the relationship in today's class only, but not now, later on. But there's actually a relationship between momentum and force also. That's why their units are quite similar. Kg meter per second square for force and kg meters per second for units. Other than that, this is the SI unit for your momentum. Other than that, there's no actually derived unit, like named after the scientist or anything, nothing like that. This is the only SI unit or base unit for momentum. Now, there's this one little question we're going to solve. It's very easy. I mean, I just included this for a little bit of practice. It is that calculate the momentum for a 1500 kg car. This is the mass. and traveling in a negative x direction with a speed of 20 meters per second. This is the velocity. But over here, velocity will not be plus 20. It was already stated in the question, which is in the negative x direction, right? For negative x direction, obviously the value of your velocity would be negative. That means the final momentum is going to be 1500 multiplied with minus 20. How much is that? Can anyone please calculate this and let me know the value?
Negative 30,000.
Negative 30,000. So, negative 30,000, obviously kg meters per second. Now, in this situation, the negative over here does not indicate that over this entire time, the value for your momentum is changing or decreasing. The magnitude for momentum is decreasing. Sorry, 1 minute. Sorry, as I was saying, that for this entire time, the negative sign over here does not indicate that your magnitude is decreasing, right? It is not going to be considered as the number theory, like we understand in maths, right? In maths, what happens if an object's value is decreasing from like 2, 1, 0, -1, -2, we consider the magnitude of the number is decreasing, right? But in physics, that is not the case. The negative sign over here only represents that maybe in momentum, as this is a vector quantity concept, right? In momentum, if you took the direction towards right as positive, over here the object is moving towards left, right? So there's actually a one assumption in all the maths for your momentum. You have to consider one particular direction as positive, and that is not fixed. You can consider any direction to be positive or any direction to be negative. Okay. From my understanding, I'm going to consider that direction towards right as positive. That means your final answer came out to be negative. You can also write this answer as 30,000 kg meters per second towards left, right? The negative sign over here in front of the magnitude represents the direction only. So if we're going to represent the direction in words, then there's no need to write the minus sign in front, right? Both of them indicate the same thing, only over here the direction was involved with a negative sign, and over here the direction was involved with words, right, towards left. Both can be written in your answer paper and you will get marks for both of them. They will not cut your marks for writing in this format or in this format. Both are correct. Now we'll move on to your last, these are actually the basic things. Now we're going to understand with our a little bit more tougher parts. That is the principle of conservation of momentum, of linear momentum specifically. This is actually a 2-mark question. Okay, this is a repetitive question for Unit 4. In Unit 4, as I've already stated that Unit 1 and Unit 4 are kind of similar. In Unit 1 also you have like what, 80% maths, 20% theory. Similar to Unit 1, in Unit 4 also, they have 80% maths and 20% theory. Among this 20% theory, they have this, like very less theory. So what problem is that they face is they don't have that much, like different type of questions they can arrange that they can make. So before our exams, what we will do is that I'll give you a list of facts. So you can actually memorize that facts, and I'm quite sure that you're going to get something common out of those facts. Because in Unit 4, it's very easy to predict that what questions might appear in your exam paper, as they do not have that much theory. But for your Unit 5, it's difficult because for Unit 5, we have a lot of theories, a lot of memorizing thing that they have in Unit 5. So for Unit 5, the facts are available, the facts are useful, but only using a fact in Unit 5, we'll get like what? 30 marks on maths or 20 marks on maths. Other than that, not much more than that. But in Unit 4, if they're going to like maybe ask you 12 marks of theoretical question, you can actually get 12 marks of theoretical question by memorizing the facts. Because it's so obvious to understand like what are the theories that will be asked in your Unit 4 question papers. The maths are unpredictable, but the theories are very easy to understand. So now this entire thing, like the conservation of principle of momentum, is actually one of the repeated questions. Now, in your repeated question, you're supposed to write in this way that total momentum before collision is equals to total momentum after collision. This is your 1 mark. Okay. This entire thing will give you 1 mark. And the other mark will be this one. This is your 2nd mark. provided that no external force acts on the system over here, right? In this situation, no external force can act. In collision, what happens when the objects are going to collide? Right, this object will exert a force in this direction, and this will exert a force in this direction. Only they can exert a force on each other during the collision. Other than that, air resistance, friction, all of the external forces will be considered as zero. Because if you are going to consider taking those forces into your calculation, then the conservation of momentum cannot be actually uh, applied, because according in every law actually, like all of the law we have stated, all of the law we have done so far, they always have assumptions. In this situation, for conservation of law of momentum, in order to be applied on a collision, there is some assumption. The assumption is that obviously total momentum before collision should be equal to after collision. This is also an assumption because in real life this is not the case. The momentum before and after collision does not remain same ever. Okay, that is your one first assumption, that collision, sorry, momentum before and after collision should be same. And the other assumption is that energy should not be lost during this collision, right? But in real life, energy is obviously lost, right? Because in real life, during collision, sound and heat is produced. Sound and heat is a form of energy. And where does that energy come from? We cannot create energy, right? According to our law of conservation of energy, I think there was this part that we cannot create or destroy energy. We can only transfer energy from one form to another. So in real life, what happens that during collision, when they are going to collide, obviously some of the energy will be lost to the surrounding in the form of heat and sound. But that is our in real life situation. In mathematical situation, there always has to be some assumptions. Okay, so I'll just write down the assumption over here. One minute. First one is momentum before and after should be same. I'm just writing same over here because I don't have much space. And for the second part, that is energy should be conserved during collision. Okay. Energy should be conserved during collision. Now, this assumption is also very important. In some questions, this is also like a repetitive part. In some questions, they will also ask you that what are the assumptions for your uh, law of conservation of momentum. So this is extremely important. This entire thing, these two in combination, 1 minute, this two in combination will get you 2 marks, and this entire thing will get you 2 marks. This is basically a 4-mark questions. When they don't ask you as a total, that these things and this thing will not be considered as a total 4-mark question, but they will ask you as two separate questions, 2 marks for this, 2 marks for this. Right. Other than that, is there any problem so far?
Enormous.
I think Nafisa, you joined the class right now, but you actually have to watch the recording after this. Okay. So I will upload the recording in my public YouTube channel at Excel Easy. So you guys, all of you can actually watch this recording from the very start. Um, but other than that, if you want to get this file, you need to like WhatsApp me. So I hope you have my number. Okay. We're going to start with the collisions now. I mean, obviously, the collisions are quite easy. You understand that. But there are basically three types of collisions. Okay. The first one is this one. So in first collision, what happens? This is the before collision part and this is the after collision part. In before collision, we can clearly see that two particles were moving towards each other. So I'm going to consider this as a mass of M2 and this has a mass of M1. The masses never change. For the entire journey, the total mass of the object will remain same. Okay. So after collision also, 1 minute. After collision also, the masses remain same, M1, M2, and there are actually velocity changes. Before collision, we consider the velocities as initial velocity. So this is like initial velocity for particle 2, and this is initial velocity for particle 1. And then again, this is initial velocity for final velocity for particle 2 and final velocity for particle 1. In this situation, I can clearly understand there are two directions involved, right? And what happens is that during collision or because of the collision of the two particles, their direction of motion are actually reversed. Previously, particle 1 was moving towards left, so right, and then after the collision, it has reversed its direction of motion, and now it is traveling towards left. Similar thing happened for unit 2 also. So since in this particular example, as you have two directions involved, you need to assign one direction as positive and the other as negative. So over here, I'm going to consider the direction towards right as positive and left would be negative in that sense, which means this will be positive and this will be negative. Then again, V2, right? Yeah, this will again be positive because it was traveling towards the right, and V1 would be negative. And using this, I can actually arrange your equation. In terms of your this format, the total momentum before a collision. Total momentum means that summation of particle 1, particle 2. So I can write that sum of momentum before collision is equals to sum of momentum after collision. In before collision, you have what? Mass 1, then U1. U1 is positive, so no need to assign negative over here. As we are doing sum of momentum, right? So obviously this will be added with the momentum of particle 2. But for particle 2, mass obviously doesn't have any signs involved with it because mass is a vector, sorry, scalar quantity. But this initial velocity is going to be negative. So I'm going to consider this U2 negative. And then again on the right side, we're going to have this V1 to be negative. So this will be M1 minus V1. And then again, this will be added with M2 plus V2 because V2 is now moving towards the right direction and we consider the right to be positive. So no problem with that. Now it's going to be M2, V2. Lastly, I'm going to write the equation as M1 U1 minus M2 U2 is equals to minus M1 V1 plus M2 V2. Over here, the right, I wrote this entire line. Oh, sorry, 1 minute. I wrote this entire line over here just to explain you that at the very start of our equation making format, I'm going to add the value for your momentum for the two particles because that was your in the formula, right? Total momentum means summation of momentum before collision for the two particles. I have to add them. The problem is that maybe they were moving in the negative directions. And because of that, their velocity was considered to be negative. And that's why this particle two's entire momentum became out to be negative. And for that reason, the values of the momentum before collision and also after collision would actually have to be subtracted from each other. They will no longer be added. I mean, obviously, in your exam papers, you're not supposed to write all these three walkthrough. I mean, you can obviously, by practicing the question paper, you would understand, Jay, for which question you have to use which equation. For which situation you have to use which equation. For example, whenever the particles are moving in opposite direction, they will no longer be added together. They will actually be subtracted. That's what happened over here. I originally started with summation, but eventually, because of the negative direction, they were canceling each other out. They were canceling each other out. Is there any problem from scenario 1?
No, miss, it's clear.
Thank you. Then we are going to start with scenario 2 now. Okay, for scenario 2 now, we can see that this second particle this time is not in motion because it doesn't have any arrow above it. That means the second particle was stationary. The first particle was moving towards the second particle, and then again after collision, what happened? They again starts moving in the opposite direction. A similar process, I'm going to be assigning these particles with their masses and velocities. This is M2, this is mass 1, then again this is mass 1, mass 2. This time the velocity of G2 is 0 and U1 is something, I'm not sure what it is, but it has some magnitude. And in after collision, this is your V2, now it has a magnitude, and this is V1. Similarly, I'm going to take direction as right towards positive. In most of the cases, in most of the maths, I consider taking right as positive, but that is not a fixed case, by the way. Okay, you can take any direction to be as positive, left as positive, right as positive. That is up to you. In that case, this one U1 will be positive, V1 will be positive, and V2 will be positive, and V1 will be negative. And as V1 was moving towards right, so it was moving towards left, and V2 right as positive. So this is in the opposite direction. So V1 turns out to be negative. Now over here again, I can create the same equation that sum of momentum before collision is equals to sum of momentum after collision. So for this part, similarly, we're going to start with M1, M1 U1. It will not be assigned with anything negative because U1 was entirely positive. This will be added with M2 multiplied with 0. There's no point of writing U2. The value for U2, initial velocity for particle 2, was 0. So let's write 0 over there. And this should be equal to M1 minus V1 plus M2 V2. You can clearly understand over here, this one will be entirely cancelled from the equation. It is multiplying anything with 0. Doesn't matter how big the value of your mass 2 is, right? Doesn't matter. If you're multiplying that with 0, it will eventually be 0. So now this final equation would look like M1 U1 is equals to minus M1 V1 plus M2 V2, right? This is how the equation would look like. So this is scenario 1, scenario 2. Is there any questions from scenario 1 and 2?
Can you please clarify the first scenario more clearly? I don't think I got it.
Okay. The first scenario, let me identify the differences over here. Okay. That in the first scenario, what happened? Like, for example, for first scenario and second scenario, if you look at the diagrams, right? Because after collision, they're quite similar, right? They're both moving away from each other with certain velocities. Right? This portion and this portion are quite similar. Already before collision was different. For this part, before collision, particle 2 was stationary, and for this part, particle 2 was also moving towards particle 1. And for that reason, over here, you're going to get some momentum because now particle 2 has momentum. And for this scenario, particle 2 does not have momentum because you're multiplying mass with velocity.
Okay.
Okay, now, but this part again, I think Omar, Natra, I think my voice is echoing from your part. Okay, I'll explain this, and I think then after that, turn on your mic.
Sure.
Now, as I was saying, that for this part, for scenario 1, mass 1 and initial velocity will be multiplied with each other. There will be no minus sign assigned with this because this is moving in the positive direction. Listen to me. Wait, I'm really sorry. 1 minute. Wait, sorry, no. But as I was saying, now this unit, unit 2, particle 2 and particle 1's initial velocity and final velocity will be negative already. From that part, this is positive, this is positive. We can see that this part is positive and this part is positive. Initial component for particle 1 and final component for particle 2 is positive. And initial component for particle 2 was negative, this is negative, and final component for particle 1, this is negative, which makes this entire product negative, and this also makes this entire product negative. Nadra, is this clear for you now?
Yeah, yes.
And then after in scenario 2, similar process happens. But this particle, in particle 2, there was no velocity. So it doesn't matter if it's going to be positive or negative, right? Multiplying, I mean, adding 0 or subtracting 0 for any value will not create any change. That's what we did over here. This is positive, mass 1, unit, initial velocity 1 positive. This is what we got over here, plus m1 u1. And this entire thing would be zero because initial velocity for particle 2 was zero. And after collision, mass 1, v1 was negative because it was now traveling towards right, and you considered left as positive. So right as positive, and this is traveling towards left. That's why this entire thing turns right, that would be positive. So the positive part, we're going to get plus m2 and v2. Is there any question from this scenario, scenario 1 and 2?
No.
Then we move on to your last scenario, scenario 3. This time, similar thing happens. The particles are going to collide with each other before they are moving in the same opposite directions. And after collision, they're going to be attached with each other. This time, they will not be moving away after the collision. This time, they will attach combined velocity. Wait 1 minute. I don't know, for some reason, my internet is turning off and on for some reason. I'm really sorry. For scenario 3 over here, after collision, the particles are going to combine with each other, and now they are going to move with a combined velocity. So this time, they will not have v1, v2. They will have a combined velocity for both the particles. Now, in this situation, if I'm going to arrange them, this is particle 2, this is particle 1. This is their initial velocities are different because for the initial case, they are traveling in opposite directions, right? Away from each other, we can see. This is u2 and u1. Obviously, I'm going to consider this one as negative and this one as positive. And for the final part over here, the total mass will actually be the combined mass for mass 1 and mass 2. We'll understand that from the equation. Let's start with this. This is m2, m1, and now they both have similar velocity. For this also they have velocity, but this also they have velocity v. I'm not going to assign it and write v1 and v2. This time they have same velocity, so obviously I'm just writing v and v. Okay, I'm not going to write v1 and v2 separately for the two particles. The two particles have the same velocity, v and v. So now over here, if you move on to writing their equations, formula was sum of momentum before collision is equals to sum of momentum after collision, right? But for this part, sum of momentum before collision, we are going to have similar concept, m1 u1 plus m2 minus u2. Right? Obviously, u2 is negative because it was traveling towards left, and I considered right as positive. And this should be equal to m1v plus m2v. Final velocity was towards right, so that will be positive. Now, in this part, I can see that v is common for both the products over here. So I can factorize it, right? I can take v common and eventually the entire equation. Wait, 1 minute, something happened. Okay, sorry. So now the entire right-hand side of the equation would change. Left-hand one will remain as it was, m1 u1 minus m2 u2. Only the right-hand side will now look like m1 plus m2 multiplied with v. Right? This time it says that after collision, the total masses are going to be combined to each other and they're going to move with a combined velocity. They're going to stick to each other and move with a combined velocity. They will not move in separate velocities. Is there any problem from scenario 3?
No.
Okay. From anyone else?
No.
No, miss.
For Safia and Tajdeep, you guys are actually my chat batch. Even if you guys have any problem, you can actually say. Safia, Tajdeep, any problem?
No.
Um,
No, miss.
Thank you for responding. Can you guys just wait for 1 minute? I'm going to bring some water and then I'll start. Okay, just 1 minute. Okay, so let's start. Now we're done with the types of collisions, right? There are three types of collision. We know how to arrange their equations. In this sort of situation, what happens is that you need to find out any of the unknown quantity. Like maybe they will not provide you with the mass, they will not provide you with the velocity, something would be missing. And from this equation, you have to make that unknown quantity the subject of your equation. And that will easily solve your entire maths. So before we actually move on to the next part, I want to solve one question from this part. This entire thing, explosions also actually is a part of type of collisions. There's actually a difference between collisions and explosion. In collisions, what happens? The two particles must be separated from each other and they would combine after the collision, or they would, stick to each other or move away from each other after the collision. That is the concept of a collision. For explosion, what happens? Previously, the particle 1 and particle 2 will be attached with each other, and after explosion, they will move away from each other. That is the basic case for explosion. For explosion, only one scenario is there. At the first, before collision stage, before explosion stage, the two particles, particle 1 and particle 2, will be attached with each other, and after collision, they will move away from each other. And usually, in most cases, in explosion, we use the concepts of this cannon and ball, and we use the examples of a bullet and a gun, right? This kind of equations or scenarios are used for explosions. For example, for this case of over here, I can create an equation and then again I can solve it to find out the unknown mass of this cannon. Over here, the mass of the cannon in kg was missing. Okay. Now, in this part, I can understand that this is going to be what? I'm going to consider this as mass of particle 2, mass of particle 1. And previously, what happens when they are not exploded? Before explosion, they are both stationary. For explosion, this is mostly the case. So before explosion, the two particles are actually stationary and now they have combined velocity. This is basically the opposite of scenario 3. But in scenario 3, after collision, they have combined velocity. This time, before collision, they're going to have combined velocity. So this is going to be u and this is going to be u. And after collision, they have different velocities. This is v2, sorry, this is v2 and this is m2 and this is going to be your m1 and this is v1. Okay. Similar process, we are going to start with total momentum before and after collision. Sum of momentum before collision is equals to sum of momentum after collision. So, okay. Now, for before collision, if I'm going to arrange that same equation process, also over here, I'm considering direction towards right as positive, right? I think that is visible on the screen. So, in this part, M1, I mean, at the very start, M1 u plus m2 u. Even though the initial velocity is 0, but I'm just writing the equation over here, right? And after collision, this is going to be v1 is negative, right? As we can see from the magnitude, v1 is negative. So m1 minus v1 plus m2. This v2 is positive, so there's no point of writing that inside brackets. Eventually, it will be I can take initial velocity common before collision. So it will be m1 plus m2 multiplied with 0. And so multiplied with 0. I'm going to introduce a magnitude right away. And this one will be m1 v1 plus m2 v2. But is there anyone still having any questions about how I arrange this equation? If there is any problem about the arrangement of this equation, please ask.
Yes, please. I didn't get it.
Why? Where did you find the problem?
Sorry?
I mean, which part? Which part?
Oh, the arrangement. I got a bit confused there.
Okay. Explosion is basically the opposite of collision. In collision, what we saw, let me in collision, we saw that before collision, their particles were moving towards each other, and after collision, the particles may be combined with each other, and then they're going to move with the combined velocity, right? That was the case for your before collision and after collision. In explosion, what happens? This is exactly the opposite. This is your scenario for before collision. As you can see, in before collision, what happens? Obviously the diagram is not that much accurate. As you can see, this ball was actually kind of projected out of this cannon. I'm actually assuming over here that they are still together. Okay. I'm actually going to consider that this one, I cannot actually move it. 1 minute. I'm going to consider that this entire ball is still in contact with the cannon. Okay. This is before the explosion, before that cannon has actually ejected that ball away from it. Okay. So this is before collision. Before collision, what happens? They're still in this ball is still inside the cannon, right? If this ball is still inside the cannon, in that case, now they're both are stationary. Right? In that case, since both particles, particle 1 and particle 2, as they're both stationary, we can consider they have the same velocity, right? So they have the velocity u and u. Initial velocity is same for both of them. Is this part clear to you, Nadra, so far?
Yes.
Nadra couldn't listen to you. Is this clear?
Yes.
Okay. Then after collision, what happens? When this cannon is going to explode and eject that cannonball away from it, now this cannonball will move in the rightward direction and this cannon will move in the left direction. They have their particular masses given 800 and x kg, the mass of the cannonball is missing, and you have their final velocities. The final velocity is different, right? But the cannonball, the velocity was 30 or v2, and for the cannon, the velocity was -4 or v1. So that's what we wrote. Only v2 over here is positive. After velocity, after collision, v1 was negative. That's why you can see v2 is positive and v1 was negative. And then again, before collision, what happens? They were both actually moving with same velocity. I mean, there was no motion, right? The velocity was 0. So we can consider they have same velocity, which is 0. That's why I took out this u common out of this m1 and m2. Eventually, this is how the total equation for explosions would look like. Is this clear?
Yes.
Now, in the second part, we can find out the value for your x, which is basically the mass for m2. In this situation now, I'm going to write what? Similar case. Obviously, the right-hand side will be 0 because m1, m2 doesn't matter whatever the big value is. It is getting multiplied with 0. Something getting multiplied with 0 eventually turn out to be 0. Right? So this entire thing will turn out to be 0, which means now in the second part, right-hand side is entirely 0. Left-hand side, m1, v1 was negative. So we are going to get minus 800 with 4. Right? This is your m1, v1. This was negative. Plus m2, v2. This is supposed to be mass 2. Mass 2 is x. So this is x multiplied with 30. Eventually, what? 800 with 4 gives you 3200. I can now rearrange the equation. This is going to be, I'll just take that 800 with 4 to the left hand side to make it positive. So 3200 is equals to 30x. I'll flip it 30x is equals to 3200. Eventually, the value for x would be 3200 divided by 30. And that should be approximately 106.6667 grams. I'll consider writing this as only 107 kg. Okay, that was the mass of your cannonball. This is how all of your equations will actually be. For every case, there would be at least one component missing, and that you have to calculate. So you just have to rearrange the equation and make that unknown alphabet the subject of your equation. Is there any problem from this explanation?
No, miss.
So this is it for all the scenarios for collisions and explosions. Okay, we're going to move up. I will actually remove this. Did I need this space? This is about impulse. We have an introduced impulse. Let's move up and then we'll again move down for this calculation parts. Okay, now this is about change in momentum. Now what is change in momentum? For example, we start with this example 2. In example 2, we can see that there's one particular car at two different positions. This is position 1. And this is your position A. Sorry, position B. In position 1, the mass obviously remains constant, right? At every point, the mass remains constant. So this is going to be mass. At position A, the velocity was maybe 20 meters per second. And at position B, the velocity was maybe 28 meters per second. We can clearly see over here, the object's velocity was not similar, right? The object's velocity changed over time. So in this situation, if you want to find out the momentum of position A, for example, I'm going to consider the mass of this entire car with the man is maybe 10 for my easiness of calculation. This is 10 kg and this is also 10 kg. Mass never changes. So for momentum, I can get what 10 multiplied with 20, that would be 200 kg meters per second. And for this part, we're going to get 28 multiplied with 10, so 280 kg meters per second. We can clearly understand over this entire journey, the momentum was not constant, right? The momentum has changed. So in this kind of situation, for a particular journey, when the momentum is not constant, you can actually calculate the value for your change in momentum. So for this case, change in momentum is represented with this equation. Delta V, this is your final momentum, and this is your initial momentum. Initial momentum uses your initial velocity, that's why it is named after initial momentum. And final momentum uses your final velocity, that's why it's named after the final velocity. Right? So using this equation, we can actually find out the change in momentum for this example. Change in momentum is actually mv minus mu, which is 280 minus 200. That is eventually going to be 80, right? Yeah, 80 meters per second. That is a value for your change in momentum. Now, change in momentum can only be achieved if your particle is moving with changing velocity. If the velocity changes of a particle, in that case only we can find out the change in momentum. In the next scenario, I will actually make it move with constant velocity. In this example 1, I'm going to consider the mass of this car with the old lady will be again maybe 10 kg, and your initial velocity over here is going to be like 20. Similarly, mass over here is again 10 kg, and final velocity over here is still 20 meters per second. One important thing to understand in this part is the velocity didn't change, right? At position A and at position B, this is by the way position A, and this is your position B. In position A and B, the value for your velocity remain constant. So if I want to find out the value for your momentum in initial position and final position, in that case, we're going to get 20 with 10, that is what, 200 kg meters per second. And over here for 20 with 10, that is again 200 kg meters per second. So these two situations, we can understand that there is no change in momentum occurring. So if for this situation, I still want to calculate that what would be the change in momentum over here.
Zero.
Right, 0 meters per second, kg meters per second. That means change in momentum can only be applied to situations when the object is moving with different velocities for the entire journey. And when the velocity of the object is changing, only in that cases we can calculate the value of your change in momentum. And for situations when the object is moving with constant velocity, it would never have any change in momentum. Right? The change in momentum over here would be 0. Alright. Is there any problem from this part? Please look at this entire process and let me know if there's any problem.
Miss, can the mass change in any scenario?
The problem is obviously mass can change, but in most of the cases, in linear momentum, we're only working with particular objects on ground. So in that cases, mass never changes. But if you're thinking about a rocket, right? In a rocket, what happens? At the very start, the rocket has mass combined with. Actually, let me just go to an empty space over here. A rocket at the very start of its journey. Okay, the mass of the rocket is basically the combination of the parts, all the parts that are actually needed to create the rocket, and also the mass of the fuel is attached, right? That will give you the total mass of the rocket. But during the journey, in order to create thrust to move out of that gravitational force, the rocket obviously needs to burn fuel. And if the rocket is burning fuel, the mass of the fuel will drop down. So eventually, after the journey, maybe over here, the rocket's mass was like 500 kg, and after the entire journey, the rocket's mass will only have the parts, right? It will not have any fuels left in it. The entire fuels will be cancelled out. And in that cases, maybe the mass will be changed to what? 25 to 250 kg, right? So for this kind of situations, if the value for your mass is changing, mostly related to rockets moving in outer space, burning fuel, all these concepts will be related for your change in mass part. Whenever your mass changes, obviously that will cause the value of your momentum to also change. But this is very specific to only one example, right? Whenever the object is working with the rocket. Other than that, these are not that much common.
Okay, Miss, thank you.
I just removed this, okay, because I need this space. I mean, again, if I go back to the first part, actually, according to your equation, right, the equation was what? Um, Momentum, mass, velocity. So if momentum is equals to mass times velocity, that means if any one of the quantity changes, momentum would change, right? Because momentum is directly proportional to mass and velocity. So obviously, I mean, in this situation, I was only explaining you that how change in velocity will only create change in momentum. That will also be possible, as Bishama says, that a change in mass also it will create change in momentum. Right? Is there any problem?
No, miss.
I think I should write this somewhere, but I don't have much space. 1 minute. Change in mass, either change in mass or velocity will create harm. I'll just write this down over here, okay? I'll just write delta P. Delta P always represents change in momentum. So this is it for your change in momentum part. They will actually ask you to calculate few maths about change in momentum, but not that much required. Change in momentum is actually a pre-elementary concept for your impulse. But I think in ACE we know, yeah, in ACE we are not discussed with impulse. In IGC also, we are not discussed with impulse, but I think those of you who have or had maths M1, they already know what impulse is, right? So for impulse, this is basically change in momentum, but actually in impulse, what happens? Or during the collision, what happens? As I've already stated that during the collision, we are obviously not going to consider any external forces acting on the particle. We're only going to consider the forces that are acting because of the two particles. For example, I've already the diagram over here. We can see a basketball and a tennis ball, right? They are colliding with each other. In this situation, the basketball will provide a force on the tennis ball in this direction, and the tennis ball will also provide a force in the opposite direction on the basketball. According to your Newton's third law, if the basketball is going to provide a 5 Newton of force on the tennis ball, but in this direction, in that case, obviously, the tennis ball will also exert the same magnitude of force on the basketball in the opposite direction. If you guys remember, Newton's third law was what? That for every collision, there is a, sorry, not collision, sorry, for every action, there is an equal and opposite reaction. Right, so during collision, that Newton's third law is a very important thing. That basketball provides 5 Newton force on the tennis ball towards the right, and therefore, as a reaction, tennis ball will also provide a 5 Newton force on the basketball towards left. And the magnitude will be same, but in opposite directions. And again, this type of force, like the tennis ball and your basketball, will only exert this 5 Newton force on each other for a particular time for which they are in contact, right? That is your actual concepts for impulse. Impulse can be calculated in two different equations. Okay, 1 minute. First equation is this one. Impulse is change in momentum. That is basically from the previous question, I can understand that impulse, actually the symbol for impulse is capital I. This is equals to mv minus mu. That is the first equation for impulse. And the other equation for impulse is like for how many times they were exerting forces on each other. That can also be used to calculate the second equation. So for the second equation, impulse is I, 1 minute, I equals to ft. This is your second equation. And obviously from the first equation, the unit is kg meters per second. And for the second equation, unit is what? Newton second, right? Force into time. Force is measured in Newton, time is in second. So for this part, unit is Newton second. But how can one quantity have two different units? They do not actually have two different units. They're quite similar. For example, you can break down Newton and extract kg meters per second out of it. Newton is the derived unit for force, right? So I can actually break down Newton as mass acceleration, which is kg meter per second square. So from this part, Newton second, I can actually write this as kg meter per second square actually indicate that this is in this format. Meter divided by second square, and this will be multiplied with another second. And clearly understand, seconds cancelled out, and at the base now you have 1 extra second. Right, there's 1 extra second left, which is eventually going to create your kg meters per second. So at the end, Newton second is basically like a derived unit, which you can break down and simplify to write it in the form of kg meters per second. So at the end of the day, yes, obviously using two different equations will get you two different units, but they're quite similar, right? They can be derived from each other. Now again, after this, as I can clearly understand, I have two equations for the similar quantity. I have two equations for both for impulse. So I can now use our simultaneous equation basics from our IGCSE maths. So I'm going to write I equals to I, that is going to be mv minus mu is equals to force into time. So I can use this type of equation to find out any unknown quantity. Maybe the force will be unknown to you, or velocity or time, any of this quantity will be unknown to you, that you have to find out using this equation. Substitute equation 1 into 2. Okay, we did substitution over here. So any problem from anyone from this part? Okay. These equations are quite important. You need to understand or memorize these equations, okay? Are very important. Now let's move on to maths for impulse. You'll obviously understand the graphs also in today's class, but um, I think we have a maths, okay? This one was your question for your impulse concept. Over here, it says that a golfer hits a golf ball that is initially at rest. That means initial velocity of the golfer was 0. And the golf club is in contact with the ball for 0.0016 seconds. That is the relative time during the collision, right? In contact means they're talking about during collision. And then after the collision, the velocity of the ball immediately after it is hit is 6.2. That is your final velocity, 6.2 meters per second. And the mass of the ball was 0.0044 kg. That is the mass of the ball given. Okay, problem is now I know that obviously they are talking like during the collision was mentioned in the question. That means obviously I have to use my two equations for impulse, right? The two equations of impulse were mv minus mu, that is your equation 1, and the other one was ft, that is your equation 2. Now in this part, calculate the impulse on the ball and 1 minute. Calculate the impulse on the ball, that is your first part, right? And then find the average force exerted by the balls on the club of the ball. Okay, now over here they are trying to find out the force also. In this part, in order to find out the impulse first, like this is your part A, I'm going to say this is part A and this is part B. So for part A, they are asking you to calculate the impulse. For impulse over here, I can use any of the equation. For this second equation, I cannot use this to calculate impulse because force is unknown. So what I have to do, I have to use my initial velocity, final velocity, and mass to find out the impulse. I'm going to use my first equation because now I have mass, final velocity, initial velocity, all available. So for your part 1, as you have the mass of the object as 0.0044 kg and initial velocity was 0 and final velocity was 6.2, I can use your change in momentum. So 1 minute. MVMU, right? That is going to be 0.0044 multiplied with final velocity of 6.2 and then again 0.0044 multiplied with 0. Obviously, this will be entirely 0. Can anyone calculate the value for me? Sorry, I wrote change in momentum. I was supposed to write impulse over here. What is the value for your impulse?
0.02728.
0.02728. Since I use that mv minus mu, so I'll just keep using that formula in unit for kg meters per second. The one thing to understand over here, if you look at the data that was provided in your question, 6.2, this was in two significant figure. 0.0016, this is still in two significant figure. This is in two significant figure. So all your questions, like all the data provided in your question, were in two significant figure, but your answer is in four significant figure. The higher the significant figure, the more accurate the data is. Okay. The higher the significant figure, the more accurate the data is. And there is no way that your answer could be more accurate than the data provided in the question because you are using the data from the question, right? That means your answer should have a more percentage uncertainty than your data provided in the question. So there's always one trick for unit 4, unit 1, for all the units for physics, and all. I think that also applies for chemistry and biology. Okay, for all the other units, this is your trick that your answer could not be at a greater significant figures than the data used, than using the data. Over here, all the significant figures that were used in the data were two, right? Two significant figures. So you should also keep your answer to two significant figure, but uh, at least, I mean, you can keep your answer as two significant figure or as one significant figure, but not greater than two. If you're going to use three significant figure also, then your essay significance figure for answer is greater than your data, and that will also be wrong. So you can only use two essay or one essay over here. You can only use the significant figure used in the question or less than that. Okay. As the question used two significant figure, it means we can keep our answer in either two essay or either in one essay, but not greater than two. We can keep it to less than two, but not greater than two. So in that case, our final answer should be 0.028 kg meters per second. That is the final answer for impulse. But for this part again, the impulse is provided 0.028 kg meters per second. And after this, for part B now, they want to find out the velocity, sorry, force. So yeah, we can find out the force also because now what? Now I have the value for impulse, right? So using impulse and time, I can easily calculate the. Just wait 1 minute.
17.5 newtons.
Just wait 1 minute, please. Coming back within 5 minutes. 1 minute. Sorry guys, there is actually someone at the door and I had to attend. You now were supposed to like you were maybe saying something. I could not actually hear you. Yulas, did you find any problems in this part?
None, miss.
Okay, so in that case, we will now start. I mean, for part A, we got the value for your impulse, right? 0.0028 kg meters per second. We're going to use that data to calculate the value for the force now. So it is going to be I equals to Ft, right? Now this is going to be, I mean, I have to make force the subject of this equation. Force is impulse over time. Impulse that you got is 0.028 divided by 0.0016. 0.0016. Yeah. Calculate this one for me then. What is the value of your force now?
17.5
17.5 newtons.
newtons.
This is your final answer. This is how you can actually look up for questions for impulse related. Is there any questions from any one of you?
No.
So this is it for impulse. Then we're going to move a little bit forward now. This was an example. So we're going to now move up to this. But there could be situations, right, that when a constant force might be applied to the object or a change in force might be applied to an object. Now, obviously, we can understand a constant force being applied to an object. How the situation for a constant force would look like. For example, that example we saw for the tennis ball, right? For the tennis ball, the objects are going to be in contact with each other for a certain period of time, and they are going to exert a force on each other, right? Same magnitude of force will be applied to them for a certain period of time. And this is maybe like F1, F2, and at the end of the day, they are of constant magnitude. That means during the collision, the value of the force exerting on the two particles will not change. They will be exerted on the two particles of equal magnitude, of same magnitude. So this is how the graph for the same constant force would look like. Just let me write this down. This is for figure 01 for constant force. For constant force, obviously you can understand force remain constant and the time changes. And over here, the area under the graph will give you your impulse, right? Area under force time graph will give you the value of your impulse exerted on the particle. So which is going to be just what force into time, y-axis into x-axis, right? That will give you the value of your impulse. So impulse over here is basically force into time. That will give you the value of your impulse. After that, in this second diagram, over here, we can understand that the value of force is not constant, right? Up to certain point, the value of your force is increasing. And then again, this is your maximum force. And after that, the force again decreases, right? Now, in what kind of situation this might occur? I think I have a figure for this one. 1 minute. Right. This kind of situations where the forces would be different for different sections of the journey. So let me just take this image and so let's just understand this and then I'll minimize it. Okay. Now, in this situation, what happens that at the very bottom stage of your piece, right, when the object is about to interact but was about to squash with the ground, over here, there are three stages actually. First one is when it was about to get like squashed with the ground, right? This is your first stage. And then in the second stage, it was entirely squashed, and now you can see the entire ball is kind of squeezed, right? It changed its shape. And after that, during rebound, it will again jump back out of the ground in this kind of way. So for this entire section, in this part, force was a minimum. In this part, force was maximum. That's why the shape changes. And in this part, force was again minimum, right? So during this type of collisions, when your object is going to be squashed with the ground, change its shape and then again rebound to its original shape, for those situations, we can consider the force is not constant. Force changes for the three scenarios that are involved in that entire collision. Is this clear? Any questions of this understanding so far? Any questions?
Miss, I didn't get the minimum force part.
Hmm. Sorry, Dishama, I could not understand.
I didn't understand the minimum force part. Like after getting the maximum force, how can it receive the minimum force? Like what's the change happening there?
Oh, that's because the object would rebound from the ground, right? During rebound, it will obviously again lose contact with the ground. So if it is losing contact with the ground, obviously the force will again decrease.
Okay, Miss.
I think that was clear, right, Vishama?
Yes, yes.
So I'll just remove this. Okay, this is not needed. These kind of situations are actually involved in this diagram. We'll just use it over here. Okay, this situation is actually involved in this diagram. As I have stated that what happens before collision, Right, in this portion, the object is about to hit the ground, so that's why the velocity, so the force increases. And at this position, this is the squashed position. The object is entirely squashed in the ground. And then again, when it was about to rebound from the ground, it was again losing contact with the ground, so the value of your force again decreases. So this is how you actually separate sections for your graph. I mean, this was quite easy to understand, right? For every point, the force is constant. But this is for a situation when the force is not constant. So this is how the graph would look like. For a better, more detailed answer, the graph would actually look like a curve because the value of your force does not change abruptly, right? Like almost all of a sudden it is 5 and then again it will be entirely 4. That is not how it changes. Obviously, it changes from 5, 4.9, 4.8, 4.3, 4.6, like this. The change will be very gradual. That's why the actual graph for a more accurate, precise solution, this is how the graph would look like. So for this part, I can actually label like these two graphs are actually similar. Okay? Post time graphs for a ball hitting a wall or ball hitting a ground, any kind of case. This is how what happens when your force is not constant. For both the situations, not constant force. Okay, they are both of stable and case. I'm just going to now labelize different sections of the force time graph. Like what happens during this entire journey for this force time graph. So this is your figure 2 for non 1 minute for non constant force. Okay. Now let's move to this part. Okay. Over here, we can understand in this figure also, this is this wall and the car was moving towards the wall and obviously during collision, the car was squashed with the wall, right? This was the maximum force that was applied on the car during the collision. And if the car was able to rebound, then again the force would have decreased, right? Over here for this car, the actual force time graph would look like this. It was not in contact, it again went to contact and then reached the maximum force. But then again, the car never moved after that. So this is how the force time graph of the car would look like. This is force and this is time. And this is the point where the car was entirely squashed with the wall. Now let's read these 5 points over here. So the first point I can see, this is the first point, right, on your graph. The ball hits the, sorry, what? Ball first hits the wall, right? This is the position from where you can see that before first point, the graph was entirely horizontal. That means that the ball and the wall was not in contact with each other. And after this point, the graph starts to increase. That means now it has some certain force. At the very start, the force is very small. So that's why it is in a very smaller case. As you can see, so in this position, the ball first hits the wall. And obviously, as it's going to hit the wall, the value of your force will increase with time. So ball increasingly deforms into the force exerted by the wall. So at this point, this now over here at the second stage, you have a higher force there that is being applied onto the ball. And then again, at the very top, this is the maximum force that is being applied onto the ball by the wall. And this is your maximum force. From this point, the ball will start rebounding from the ground, right? So that's why the direction also changes from point 3. So ball reverses direction. And then again, point 4, the value of your force decreases because now the ball is moving away from your wall. It is going to move away from your wall, so it's going to lose contact and it is losing contact with the wall. If it is losing contact with the wall, force is obviously going to decrease. That's why ball starts to return to normal shape. Force decreases because your ball is now losing contact with the wall. And then again, 5, the ball loses contact with the wall. Eventually, the entire graph becomes horizontal. Because by the moment when your ball is going to lose contact with the wall, no force will be exerted on it. So eventually, the graph will eventually become a horizontal line. So over here, obviously the same procedure happens. The area under the graph gives you the impulse. But as this is not an entirely a fixed shape. For example, over here also, if I want to find out the impulse, what would I have done? I would have used the formula half into base into height, right? This is going to be your base. That is basically going to give you delta t. and this is going to be your height. It is basically going to give you delta V, right? So in this case, I can easily use half into base into height as this is creating a perfect triangle. So impulse over here was going to be half force, which delta force, delta time. That will give you the area under the graph for this force or uh, changing force concept. But over here, this graph is not entirely a triangle. Then we have to use your approximation method. I hope from our unit 1 basics, we all know in approximation method, you either count the squares or you can actually consider as a rectangle or take it as a rectangle. In this section, what I'm assuming is, wait 1 minute. Sorry, 1 minute. In this section, I am assuming that even though this portion was not inside the curve, right? I'm assuming that these two portions, this is quite big, 1 minute. So this is like an approximate assumption. Okay, this will never give it the accurate value. So I'm assuming that these two portions were actually of same size and this portion over here will actually have the same size. Because originally this portion was added to your graph, right? But I cannot calculate that because this was a curving part. In order to calculate that, I would have to use integration. But integration is outside our A-levels physics syllabus. So we cannot obviously calculate this portion. So my assumption is that this area is actually covered in this section of my under rectangle. And this area, yellow section, is covered this under this section of my rectangle. So if from this part, I can get the value for your length and breadth. That will give me the value for your impulse, right? Forcing the time that will give you the value for my impulse. Is there any problem with this part? Impulsive. Any questions? Is there any questions from this part?
No.
Okay, thank you for responding. Now we will move on. I think I would actually be able to solve up to Newton's third and second law. We would not be able to move to Newton's third law, or after this, we have this elastic and inelastic collision. Okay, I think we can do this in our tomorrow's class, no problem, because I actually wasted half an hour of today's class in introducing the classroom and all of the syllabus walkthrough, right? So for tomorrow's class, we're going to understand with elastic and inelastic calculations, and there's again one graph, we have to understand that, and again a few maths or some questions. This is according to Newton's third law question, and this is for elastic and inelastic collision. So we're going to do this in the next class tomorrow at 10 p.m. of my time and different times of your places. And then again, after solving that elastic and inelastic concept in tomorrow's class, sorry, I don't think we have a class tomorrow, right? Today is Saturday. Oh yeah, sorry. I'm sorry. I actually made a mistake. Today is Saturday. We are supposed to have a class on Monday. That means day after tomorrow. Yeah, so we have no problem. We can finish the entire momentum on Monday class. Okay, we now finish up to this, Newton's second law. Now, in Newton's second law, what does it state? If an object encounters, if an object encounters a net force means resultant force, uh, then the acceleration of that object is directly proportional to that force. From this part, we can understand that they're obviously talking about what? F equals to ma, right? We're actually going to understand a derivation that is very easy and might appear in your A-levels also. I mean, I'm not saying that it's very common, but might appear. Okay, so this is a derivation. So let's see what exactly momentum. Sorry, made a mistake. This is actually rate of change in momentum. Wait 1 minute. Sorry, I just have to. Okay. Now, in this part, we can clearly understand what rate of change in momentum means, right? The rate, change in momentum was delta p, and when you're comparing delta p with time, that is rate of change in momentum, like how your momentum is changing with respect to time. That is what rate of change in momentum indicates. So you can actually get that rate of change in momentum over time would actually look like mv minus mu divided by mu divided by time, and then again rate of change in momentum over time over here. I'm going to continue writing delta p and over t, and on the right hand side I can take mass common. So mass v minus u over t. In this part again, mass will be over here, v minus u divided by time. This entire thing gives you the value of your acceleration. So eventually you are getting delta p over time, that is mass acceleration. And mass acceleration was again the formula for your force. Eventually you got delta p over time, that is equals to force. So this is what actually Newton's second law states, that if an object is applied with any external resultant force, the rate of change in momentum is directly proportional to the applied resultant force on that object. This is your Newton's first law, that rate of change in momentum directly proportional to the applied resultant force. Applied resultant force. Now then again, I obviously what got this equation in terms of mass velocity, right? I can also get get this entire equation or derivation in terms of force into time also, because delta v is nothing other than impulse, right? So I can write it like this, that delta v over time is basically impulse over time, which means delta v, so delta p over time is basically force times over times, and they will cancel each other out. Eventually, you're going to get delta p over time equals to force, right? Same derivation. So you can get that from both the equations of change in momentum, mv minus mu or I over t. Is there any problem so far? Any questions from any one of you?
No, miss.
Yeah, thank you for responding. Now, wait 1 minute. Just 1 minute, okay. Okay, sorry, there was some text I have to attend. As I was saying that this is it for Newton's change in momentum and Newton's second law. This is quite important. Okay, they will not ask you the derivation, but they might ask you a descriptive question that how Newton's second law is related to rate of change in momentum. We're actually going to solve one question from this topic. It is already attached with this file at the very bottom. But you have to do that in the next class, not today, because my other class is going to start within 4 minutes. So I need to stop this class And then again, the entire file will be given to you right away after the class, but this recording will be uploaded by tonight. So after finishing my 2 classes tonight, I will upload this file, this entire recording, and obviously send you the links. And for those of you, I'm not sure if Nata, oh yeah, I think Nata, you have my number. For I think Nafisa who joined does not have my number. I'll just write my number over here so that she can. The country code is +88 0184200 665. Okay, this is my WhatsApp. So anyone who needs this file can actually get this because this is entirely a free class for everyone. And in tomorrow's class, I mean, not tomorrow, basically Monday's class, we're going to start with Newton's third law and momentum and velocity time graph, then kinetic energy, and mainly for our entire calculation parts for your angular momentum. Okay, then thank you so much for joining the class. I will stop the class over here. Thank you. Bye bye.
Thank you, Miss.